Okay, so in this video I'm going to try and explain the auditory system to you. So first of all I'm going to give a quick overview of the ear structures. So here is the auricle leading into the external acoustic meatus, and this here is going to be the external ear from this portion outwards. So the lateral surface of the tympanic membrane, which is this blue structure here, is the external ear, and then this portion here is the middle ear. So the more medial surface of this tympanic membrane is the start of the middle ear. Middle ear contains the ossicles and also this structure here, which is the eustachian tube. And then finally the inner ear, which is going to be discussed in more detail, is going to be formed from this part onwards via the oval window. So firstly, back to the external ear. Sound, as everyone really knows, is going to be collected by the auricle or the ear. So everyone can feel that in themselves more or less. And the auricle is going to be formed from several different parts, some of which, just quickly, this here is your tragus, and here below it is your antitragus. This here is your helix, the most outer part, and then your antihelix here, which is going to go upwards to form the crown of the antihelix here. And then down here is the lobule, or the lobe of the ear, which is where everyone gets their ear pierced. So that's just a really quick overview of the ear, which we know sound is going to enter into. It's then going to go from the external ear through the external acoustic meatus, which in the temporal bone, you can see here is this structure, the external acoustic meatus, which if you've watched the anatomy part of this website or video, you'll be able to tell me more about. And again, this is going to be formed by mostly the tympanic portion of the temporal bone, but its roof here is going to be formed by the squamous part. So just really quickly, squamous part here and tympanic part here. So once it's travelled through the external acoustic meatus, the sound is going to hit the tympanic membrane, which is known as the eardrum. And then it's going to be transferred towards the middle ear via the tympanic membrane. So sound vibrations are going to travel through here, hit the tympanic membrane, which is going to vibrate and cause subsequent vibration of the ossicles. So here this one would be malleus, incus and stapes. So these cause amplification of sound through the middle ear. And this here, the part of stapes, the end of it is called the foot plate. So the foot plate is going to rest on the oval window of the middle ear, and this is going to be how sound is transmitted from the middle ear to the inner ear. So the foot plate of stapes on the oval window causes movement of the oval window here, and that is going to lead into the cochlea of the inner ear. So this here is the cochlea, which is a bony structure within the inner ear. Again, the petrous portion of the temporal bone. So the cochlea is filled with 3 fluid-filled chambers, which you can see here. 1, 2, 3. 2 of these chambers are going to contain perilymph. So these 2 contain perilymph, and this one contains endolymph. So endolymph is produced and stored here, and this is known as the cochlear duct, which is the centre chamber of the cochlea. On either side, there's going to be the scala vestibuli, which is this one here, and the scala tympani, which is this one here. These are separated from the cochlear duct via 2 membranes. So the scala vestibuli is separated from it here via the Reisner's membrane, which is extending here, and the scala tympani is separated from the cochlear duct via the basilar membrane. So the basilar membrane is important because it contains this structure here, and this is the sensory organ of hearing, and it's called the organ of Corti. So this is going to contain millions of hair cells, which are going to be disrupted by excitation of this basilar membrane, which is going to be caused by movement of this fluid here within the chambers of the cochlea. And this excitation is going to cause a neurotransmitter to be released. The neurotransmitter in this case is glutamate. So this neurotransmitter is released and it causes afferent fibres of the cochlear part of the vestibulocochlear nerve, which is this here, to send information back towards the cortex of the temporal lobes, where it's going to be interpreted as sound within the brain. So this here is the cochlear part of the vestibulocochlear nerve. The vestibulocochlear nerve is formed by two different parts, the vestibular part and the cochlear part, and they're going to leave via the internal acoustic meatus, which is this part here of the temporal bone. You can see it on the posterior aspect of the apex of the petrous portion. And that's it, thank you.